This video is going to be just about our basic setup of the sweep gear, file naming, setting your limits, markers, and your frequency ranges. So on the sweep gear, we have our top here. We have our N female connector on the sweep gear unit and our N male connector on our phase cable here, going down to the end of our phase cable. It goes right here in the top of the unit. The unit puts out, I believe, approximately just 1 watt of power, unlike the PIM gear, where the PIM gear ends up putting out 43 watts of power. So after it gets powered on, I usually try and let this stuff set up for a warm up for about 15 minutes or so. Both the Enritsu sweep gear and PIM gear are both temperature sensitive on calibrations. So while I usually let it warm up, I'll go make my file naming and set all that stuff up. So we want to create a file that we're going to save our sweeps into. So we'll go over here to our shift button. It shows up here on the top screen. We have selected shift. We'll go to our file, which is number 7 here, and pulls up our columns on the right hand side. Save measurement, save. You can go in here and recall previous measurements, delete, and copy. So when we want to create our file name, we'll go over here to save measurement, select that. Right now our location is just internal memory, so if you save a sweep like this, it'll just put it in the internal memory of the unit, not in a specific folder. So to change that, we'll go over here to change save location. We want to make sure we're highlighted in here, internal memory. You can also go, let's say we want to create a subdirectory in Alt. I can also do that. But for this purpose, we'll just do internal memory. Over here on the right hand side, we'll create a folder, and we'll just name this training. So hit enter, and you can easily use the wheel or the arrow pad here. You can come down here and find our folder. Training, we'll hit set location. So now when we come back here to this screen, we have our internal memory and we're in folder training. So once we get that's good to go there, we will want to set up our frequency range, our start and stop frequency, and then we can also set up our markers to show specifically our transmit and receive range. So this is going to be an example of AT&T's LTE 700 megahertz band. So we're in return loss right now. We can go over to measurements. We have return loss selected. We'll go to sweep setup, or frequency distance, sorry. Frequency distance. Our start frequency right now is at 90 megahertz, and we're going to want to change that to 690 megahertz. So by selecting it here, it turns it red. And right here, it's kind of hard to see right now because there's a line, but it'll show start frequency 90 megahertz in red. So we'll change that to 690 megahertz. And you can go here and select gigahertz, megahertz, kilohertz, hertz, but we're just working in megahertz. We'll select enter. So our start frequency now is 690 megahertz. We'll go to stop frequency, which in this case is 755 megahertz. Let's go 755, enter. And now when we go back to our measurement screen and we're in return loss, we are sweeping from 690 megahertz to 755 megahertz. So you can see our marker 1 right there, and we'll set up our markers now. So our marker 1, show that again, escape out of here, say we're in frequency distance, we'll go back to our markers. So marker 1, select that, and if you hold that down, turns it red, and our start frequency is going to be 697. Yeah. So our marker 1 now is it's 696.972, but 697. So our next marker, go here 2, and that is going to be 715. So right there between marker 1 and marker 2 on our bandwidth, that is our transmit frequency range. Go marker 3, It's going to be 727. And last marker 4 is going to be 745. So that will show us on our left hand side between marker 1 and marker 2, that is our transmit side. 3 and 4 here is our receive side. And that comes into play on when we do some higher stuff, or even on 700 if it's amplified by a tower top amplifier. Usually you'll see between marker 2 and 3 it'll go above your limit line, but we really don't care about that since we're not working in that frequency range there. With this LTE specifically, we're worried about just between marker 1 and 2 and 3 and 4, not between 2 and 3. So to set up our limit to know if our sweeps are passing or not, go Shift, Limit, and right now we have our limit off, so we'll change it to on. And with AT&T, they want us to sweep stuff at a limit of 15.5 dB. Just go 15.5, so that drops our line down to here. So now at this point, our sweep gear has been warmed up enough that we can calibrate it. To calibrate it, we use a sweep, short, load, and open. There's several different types. We have a open load here, open short here, and then we have our sweep load here, which is not to be confused with our PIM loads. PIM loads are the big black Inritsu ones. We also have a PIM Pro one that's even larger than the Inritsus. We just want to make sure we never get these swapped between the two, because the PIM gear will fry the sweep gear load in about a second, and they're very expensive. So that's one thing to make sure that we're always on the same page of with a sweep load on or a PIM load on. And there are two different types of connectors we mainly deal with. This right here is a N as in Nancy, male connector, and that is also a N male connector. This is a DIN, D-I-N, male connector, and this would be a DIN female connector. And when you're looking at these, you don't want to look at the threads, you want to look at the center conductor here, showing that that's the female connector. And again, this is a sweep load, open and short, and as you can see, it's kind of hard to read these letters. The one thing you can know the difference is the short is always going to be the short portion here, and the open is going to be the longer portion here, and the load is always on the bottom here. So short side if all the labels come off, open is long side, and then bottom is load. So to calibrate this, we're going to go down to Shift Calibrate. We just always want to do Cal type standard, do start calibration, and pull up a screen here. And so, I always have done this 100 times, thousands of times, but I always read and make sure we're on the same. I put on what it asked me. If you put on the wrong one, you end up having to reset the unit and lose all your saved data. So it's asking me to connect the open or InstaCal. We do opens and shorts and loads. So I'll put my open here on the end of my phase cable. Go ahead and select enter. Asking for my short now. And all the sweep gear connections you can just do hand tight. Pimming is the stuff that we want to make sure we blow out in torque, but sweep gear we can just do hand tight on connectors. So it gives us a calibration temperature range. Once it goes out of that temperature range, it will tell you your calibration is off and need to recalibrate. So as we see here on the bottom of the screen, that our phase cable is calibrated to our sweep unit. It also calibrates so that you know the end of your line is right here. This is the beginning right here at your connector. So when we screw that off, we can see our frequency start to change when we loosen that connector. And that's what some of the sweep gear tests for, is a very loose hand tight connector, and very, very loose. It'll show you, it looks like it's on here, but we're showing a bad sweep. It'll show water and lines. It'll show torn jackets, torn outer jackets. So as far as figuring out where our issue is, it's hard to see when it's so short of a line, but we see our sweep come down here, and we're showing that it's sweeping good, and when we screw it on, it's showing it's perfect. If we had a failing sweep, we want to try and figure out where that failing, why it's failing and where it's at. We will go over to our measurements, and we'll go to our distance to fault. And on distance to fault, we want to set up our cable type. So down here in the left hand screen, we'll select our cable type, and we go to our cables. And you want to set your cable type to what the majority of your antenna line system is. So normally you'll have a 1/2 inch jumpers in the shelter, then you'll either have a 7/8, inch and 5/8 running up the tower. We've seen some weird stuff like 1.25" going up the tower, but normally if we're sweeping a regular tower and it's got 1 5/8, that's what we set our sweep gear to. So we'll go down here, and most of the cables have part numbers on them, so we'll go down here to AVA 7-50, which is 1 5/8 coax. We'll select that. So right now our distance is at 0 feet, which is 0 is our base cable tip right here, and our end distance is at 50 feet. So it's only sweeping 250 feet. So when we want to change that, we'll go down here to frequency distance, and we will go to stop distance, and we can change that from 25 feet all the way up to 600 feet. And normally you want your distance set on here about 20 to 30 feet further than what you think your antenna is set at. So right now we're showing an open at 0 feet right here, and we can also do a marker to help us figure out where that is at. So we can go up here to our markers, and right now our marker is at, up here it'll tell you marker 1, 25 dB at 39.27 feet. So we want to figure out where our open is, which we know it is right here. We can go marker, and we can move our marker 1, which we have underscored right there, to our peak, which is at 0 feet. So if we have a failing return loss, which we do, it's flatlined all the way at the top, reading at, we can show our markers, turn our marker table on. All our markers are at 0 dB. So we want to figure out where that's at, figure out where our fault is, distance to fault. We'll go to distance to fault return loss. We can move our marker and move it to the peak, the worst connection, and it'll show us where that's at, which is 0 feet. So when we put our sweep load on here, same thing with return loss, we'll see it slowly start to bring down, and now our connector is at 33 dB, which when we first started, it's at 0 dB. So anything with the sweep gear, PIM gear, further away from 0 the better. So right now it's sweeping a perfect sweep since our phase cable's calibrated. And for file saving, so if I want to go in here and save my return loss measurement, I'll go over to Shift, File, and select Save Measurement. You can do Save Measurement As, but that will pull up, or save it as what you previously saved your last sweep. And we always just go Save Measurement. So we'll go Save Measurement, and right now we just have internal memory, and I always check this. We have internal memory and we're in folder training. And we can go to our quick name matrix, which makes this go very fast. So you can customize all these quick keys. So if I want to change this label here, RH, or any of these, we'll change this RXAAT button, hold it down, and then quick name, we can change that to phase cable or load or anything we want to, or a color code that we use a lot. Let's type in some random stuff, enter. So now we have that soft key, that quick name right here that we can use and pull up. So if I want to save this, so this is our phase cable. I am sweeping it at a return loss with a load, so I'll go phase cable. I have my load on. If I had my load on at the antenna, I put load on at the antenna. So phase cable load underscore, I'm measuring return loss underscore, and let's give this a color code and line designation. So this will be 1.1, and you can come over here and on the soft keys type in your numbers. It's quicker than going back to the other screen. 1.1 underscore, and we'll do just red gray, which would be red GRY. Enter, and successfully save file into internal memory training folder. So lastly, for copying our save sweeps into a thumb drive, there is a USB port up here by the power connection. We'll go back to this go shift file again, copy, and here it'll pull up what files we want to copy, and this is where our destination is. So if I had a flash drive in here and I wanted to copy IBM, I'd select IBM blue, I'd select down here with my finger, and then you can collapse this, and normally when you have a USB drive in there, it'll say USB, and then you can select copy and it'll say copying into your USB thumb drive. And the other thing we can do also is save this preset. Say we use this preset a lot, and I want to go in there and enter my frequencies every time I come to a site. I can go shift preset, come over here, save setup, and you can select it in your folder, or you can go back, change save location. I want to save this in my internal memory so I can find it easily. Hit set location again. Right now it's internal memory, and I can save this setup as a preset, so I can come back and recall it every time without having to manually put in those numbers. So we'll save it as training preset. And so now if I want to go recall a setup for, let's say, a different frequency like my 1900 UMTS, I can go over here, shift preset, recall setup, and scroll down here to the bottom, and we can go our AT&T 1900 megahertz preset, and it'll automatically change all my markers and frequency. So now instead of the 690 to 755, I'm sweeping at a 1840 gigahertz to 2000 gigahertz, or 2 gigahertz, sorry. That would also, 2000 gigahertz, 2.0 gigahertz is the same as 2000 megahertz. But like I said, it just shows up here, brings in your preset you saved previously. And again, we can show our markers, we can show our marker tables, turn our marker table on, and that'll pull up our markers here. And the other note I forgot to say is when you change your frequencies like that, let's go from that 700 megahertz span to this 1900 megahertz span, we have to recalibrate. So it'll show up non-calibrated anymore, and you'll see, even though I have my load on here, it's not sweeping at a perfect sweep like it should with the sweep load on the phase cable. And as far as deleting sweeps, same thing, shift file, go in here, delete, and you can go in here and either delete a whole file by hitting select and deselect, or you can hit enter, open up that file, and go in there and delete a specific sweep that you do not want on there. And same goes for if you want to recall a measurement to see what you just swept. We can go up here to see, find one with the 1900 megahertz to show that spike in between the two transmit and receives. Tapped and bind. So open that up, and then we have a system return loss here. So this is sweeps that's been previously saved. It'll pull it up for me. And so here we're showing this is a 1900 megahertz span on a UMTS. This is on a system sweep, so it's sweeping through the whole antenna, all the lines, TTAs, diplexers. And here, even though this middle spike is above our 15.5 limit line, it doesn't matter. That is part of the TTA. So I'm specifically looking for, or at 1 to 2, which that's all fine there, and then I'm looking at 3 to 4, and that's all fine there. So that'd be a passing sweep for AT&T. Verizon has different specs as far as what they want their limit set at for return loss. I think it's maybe 18 dB. And again, to change that, we can go shift limit, single limit here, select it, turns red, and we can turn it to a 18 dB limit here. And according to Verizon, this would be passing for them. And again, another thing, just reiterate that that is the sweep load. We don't want to get those confused with the PIM loads. The PIM gear will fry the sweep load. There's one more thing I wanted to add to the sweep gear setup. Would be the adapters for the end of this phase cable. Right now it's just set at a N style connector, and that is a female. In all the kits, the sweep gears, we have the Inritu soft case here, and we can change our phase cable end. So normally it is just a DIN female connector that we're using to adapt ours to an N, or a DIN female connector that we're adapting so we can sweep onto a DIN male connector. If we need to change it to an N style or a DIN male in that kit, they have different adapters, and this would be a DIN male, and you hold the base of the phase cable here, spin that off with the silver nut, and they are quick connects. So there's very few threads on it, so we want to be careful not to cross thread these, but we just put it on there, tighten this down, and now instead of a DIN female connector, we have a DIN male connector. Again, that's all in the case there. There's, I think, 2 more in there. One to change it to a N male connector. So here's our adapter to go from the phase cable end connection there, and that is to adapt it to a N male connector. So I think this one's going to be copying sweeps onto a flash drive. So start out with just inserting the USB drive up here in the top of the unit, and I'm going to go shift file, go down here to copy, and we covered this in the video yesterday a little bit, but I didn't have a flash drive. So I want to go scroll down to my file I want to copy. It's going to be tapped and bind. Highlight that blue there, come down to this bottom window, select that, and you can either hit enter on your internal memory and make that collapse so you don't have to scroll all the way down, or you can scroll all the way down to your USB drive here, and we'll go over to copy. I'll say copying tapped bind to USB tapped bind, and that is it for getting sweeps onto a USB drive.